Today, the workshop is going to be presented by Jim Garrett, the Principal Solution Architect at Red Hat. Just a quick note, if you can, please keep yourself on mute. We don't want to embarrass our pets for making any impromptu appearances. Most of you are probably already familiar with TxMQ. We are an IT solutions provider, help to plan, build, integrate, and manage new technologies for our clients. And among the many technologies we work with, Red Hat offers some of the best available. We're constantly working to find better ways with our clients to build, manage, and scale complex systems and processes throughout modernization efforts. And great, that's exactly why we work with Red Hat as a partner. Very happy to be proud to be part of that. The platforms and solutions are really helping businesses simplify, speed their modernization efforts, and create new opportunities for organizations. So without further ado, I'm going to pass it over to Jim. You can take from here.
Oops, hold on one second. Good afternoon, everyone. My name is Jim Garrett. Let me just bring up my presentation momentarily. All right. So first of all, thanks everyone for coming to this presentation today. Appreciate your time, and I hope that by the time that we're finished with this discussion, I hope that you would have learned something about our Ansible Automation Platform. A little bit about me. I am a Principal Solution Architect at Red Hat. My email, if you want to send me any questions, is jgarrett@redhat.com. And just so you understand who I am a little bit better, I've been doing enterprise architecture for well over 30 years. And actually, let me turn off my video before I get started here. Hold on one second. Where are you? Here we go. Okay. So I've been doing enterprise architecture for well over 30 years. My first job was in that very small building you see in the bottom corner of this image, which is I worked in the U.S. Pentagon. That was actually back in the late 80s. And for those of you who were around working back then, you may remember the Iran-Contra hearings. That was actually the point in time when I started working at the Pentagon. Interesting side story, if you guys remember Oliver North, you remember his secretary, Fawn Hall. I was a 19-year-old college kid at this point in time, and I actually sat next to her and had lunch during this point in time. So just a little known fact. I like doing anything pretty much outside, from skiing to motorcycling to running. And at one point in time, I actually hiked the Grand Canyon from rim to rim. Today, what I hope you learn by the time that we're done with this presentation is we're going to talk a lot about Ansible. We're going to talk about how Ansible can be used to do public cloud provisioning, how it can be used to convert shell commands to Ansible commands, retrieving information about hosts, deploying applications, doing some self-service, and also an overview of system roles and an overview of Red Hat's insights. But the real question is, what is the Ansible Automation Platform? And first of all, I love this picture because I think a picture is always worth 1,000 words. And what I get from this picture is you have administrators who have their hands on keyboards all day long. And while they're trying to administrate your systems, they are typing the same commands over and over and over. The whole purpose of the Ansible Automation Platform is to take those repetitive tasks that people do every day and to make them a consistent, repeatable process. So some of the things that the Ansible Automation Platform can do, it can automate your IT infrastructure. This includes provisioning of your virtual machines or your cloud machines. It can also be used to administrate and configure your networks, such as F5, Arista, and Cisco. So these are just some of the general use cases. We've also got use cases where we can leverage Ansible to automate the security or the hardening of your environments and your systems. But to talk about this platform, the first question is, what does it do? And of course, it's an automation engine. But the real question is, automate what? This page talks about some of the different automation use cases that we have. The first one is orchestration. And with orchestration, you have to realize your configurations alone don't define your environments. You need to find a way to define how multiple configurations interact and ensure that your different pieces can be managed as a whole. And this is where Ansible comes into play. Ansible helps to take that complexity and bring order to it. Another use case is configuration management, where you're going to take your centralized configuration files that you want to manage, and you want to create, again, a consistent, repeatable process to manage those files. Application deployment. All of us have deployed applications in the past, and as you probably well know, when you deploy an application, first it may start in a development environment, then it goes to a test, maybe to a pre-production, and then to a production environment. Wouldn't it be great if you could create an automated process where you create that process once, and it can be used to provision all of those environments? And of course, provisioning is another one. You know, your applications have to live somewhere. If you're booting or kickstarting bare metal servers or even virtual machines, or you're creating instances from templates, Ansible and another part of Ansible called Ansible Tower can help to streamline that process. Ansible also has some plugs in for continuous delivery. For example, your CI/CD pipelines. Another great use case for Ansible. And then last but not least is security. With Ansible, we have the ability to integrate with other security devices and provide automated tasks that can be used to configure those devices. So for example, one use case that we see with security all the time is what if someone is attempting to access and do a denial of service against your servers? That typically is recognized by a log file or a log entry where some firewall is being pounded upon. Well, Ansible can be used to analyze logs. It can be used to set up different systems to communicate with one another, to push those logs out to a server. Basically do all of those very laborious manual tasks that your administrators do and automate it into a streamlined task. We also have Ansible playbooks that allow you to analyze a system and determine where its security vulnerabilities are. And then with Ansible, you can actually run a job which will then take all of those vulnerabilities and fix them. So there's multiple use cases, as you can see, that Ansible plays a part in. So one of the aspects about Ansible is it's very, very simple. Ansible is created using text files that are called YAML, which stands for yet another markup language, which means they're human readable. You don't have to have any special coding skills in order to write an Ansible playbook. And when you write that playbook, the tasks that you define in the playbook are going to be executed in the order in which they're defined. And what this enables you to do is to get productive very quickly. The average time for someone to learn Ansible and write their first playbook is about 10 minutes. Now, not only is Ansible simple, but it's extremely powerful. Again, the different use cases that we talked about: configuration management, application deployment, workflow orchestration. You have the ability to orchestrate the entire application lifecycle with an Ansible playbook. And its most valuable feature is the fact that it's agentless. And what this means is there are no agents that you have to deploy in order to run Ansible on your system. The reason that's important is that if you talk to almost any system administrator and you ask them the question, how many agents do you have running on your servers? On average, they'll say about 20. And the challenge you have is that, first of all of those agents are consuming resources: memory, CPU, disk space. if you ever have to patch or upgrade that system, you have to make sure that all of the agents will still work. So wouldn't it be nice if you had one less agent to worry about? And so with Ansible, again, it's agentless. Nothing special is needed in order to run. And Ansible can be used to manage both Linux systems and Windows systems. And the way that it does that is when it goes to manage a system, it's going to create an SSH connection to that system if it's a Linux box. Or if it's a Windows box, it's going to create a WinRM connection to that environment. And what this leads to is something we call the Ansible Way. So with Ansible, everything we do is cross-platform. It works on Linux, Windows, Unix. Again, it's agentless. It's human readable in this text file called a YAML file. And by the way, once you create this YAML file, this creates a perfect description of everything that you want to do inside this playbook. And with that perfect description, you can actually communicate information to other individuals as far as what the playbook is going to do. And since Ansible is actually an ASCII file, it can be version controlled. You can take your playbooks, which are stored as plain text, and you can check them into your source code repositories. You can version control them and leverage them any way you like in that fashion. And one of the ways Ansible works is we have what's called an inventory. The inventory is the list of servers or network devices that are going to be managed by Ansible. And these inventories literally capture all of the servers 100% of the time, regardless of your infrastructure or location. So for example, we can actually get inventories either from an ASCII file, from a web service, or from a database table. And then again, last but not least is the Ansible Way is orchestration. It's orchestration that plays well with others. At Red Hat, we're an open source company. And one of the things that we value more than anything else is making sure that our tools work well with other tools, even if it's a competitive tool. And so when I say we have orchestration that works well with others, you can see that some of the pieces that we work well with are Puppet and Jenkins, HP, SA. We basically provide hooks or links so that we can actually work well with these other tools. Now, one of the use cases that we have with Ansible that is actually not highly discussed, but it's very, very, very potent, is we have the ability to manage your network. And the thing about networks is that the way that you manage them hasn't really changed in the last 30 years. And Gartner actually went out and did a study where they looked at how different network devices are managed. And what they found was that over 71% of your network devices are managed using a command line interface. And what that means is, again, you're going to have a system administrator who has to be knowledgeable in all the command line commands that are available for each specific network device that they want to configure. So there's very few devices that have GUIs. There's very few devices that actually have APIs or other ways in which you manage them. And that alone is what makes Ansible so valuable. And the reason for that is because a lot of these network device companies, they've actually started to contribute to our open source community and add modules into Ansible that allow Ansible to manage their network devices. So what that means is we've got the experts from these companies adding to our source code tree so that we can then make it part of our product that we release to the public. Now, there's a couple of automatic considerations that we talk about. First of all, when you're talking about networks, compute is no longer the slowest link in the chain. With the invention of the internet, business demand basically that networks deliver at the speed of cloud. And to meet this need, we need to be able to automate all of the repeatable tasks. We need to create bridges that take those silos and connect them together. We've already talked about some of the common use cases, but basically anything an operator can do manually, Ansible can automate. For example, backup and restore of device configurations, upgrading a network device operating system, ensuring that your configuration is compliant. We can apply patches for common vulnerabilities and exposures. And we can generate dynamic documentation. Now that last bullet point is huge. And here's why. If you think about all of the network devices and all of the servers that a typical data center will have in it, one of the challenges you have is coming up with a report that conveys information about those devices and about those pieces of hardware. One of the features of Ansible is if you give Ansible an inventory of those servers, it has the ability to go off into those servers and generate information about those servers. For example, what's their IP address? What's their MAC address? What version of OS are they using? The list is huge as far as what it brings back. And so we have the ability to generate that information dynamically. Now, the way Ansible works, again, there's two different use case scenarios. One is with network devices. And when you're communicating with a network device, the way Ansible works is you execute your code locally in order to control the network device that you're looking to configure. The other use case is if you're trying to manage a Linux or a Windows system. And when you're managing something like that, the way that it works is it actually creates an SSH connection to that node, and it then copies a script over to that node, and then executes that script on that node, and then removes the script. Again, no agents are required to make that happen. As far as the Ansible automation engine is concerned, this picture does a great job of laying out the different components. And it starts off with something called a playbook. Again, a playbook is written in YAML, and you create or you define tasks that are then going to be executed sequentially. And each one of those tasks is going to invoke what's called an Ansible module. Now, today there are probably, I think there's over 30,000 modules which exist. I'm sorry, not 30,000, 3,000. 3,000 modules which exist. And these modules are anything from, executing the yum command on a Linux server, copying files, to provisioning a virtual machine or provisioning a cloud environment. So we have modules that handle, core infrastructure, network infrastructure, and community type infrastructure. We've also got plugins that are part of this tool. For example, the Jenkins plugin. And that's code that's going to plug into any core engine and allow certain functionality to be performed. At its simplest core, at its simplest command, we have the ability to run command line Ansible commands. And again, this picture shows we've got a management node and we've got a virtual machine, and that management node is going to connect over an SSH tunnel to that server. And in this case, we have the Ansible command, which is the ping command, which if you're familiar with different, like the Linux operating system, the ping command enables you to determine if a device is up and running. And the syntax of this command is you have the word Ansible, then you have the inventory that you'd like to act upon. And in this case, we're going to act upon all of the servers in the inventory. And then the -m stands for module. So that's the module that we're going to run. And in this case, it's the ping module. So this is simply going to reach out and touch that server and see if it's up and running. Now, a slightly more complicated implementation of Ansible is through what we call a playbook. Playbook, again, is just an ASCII file. It's in the YAML syntax. And that playbook has a series of tasks that are going to be executed. And the playbook tells the system what is the list of inventory, what's the list of servers or network devices that you want to execute these tasks against. And for every host in the inventory and every task in the playbook, we establish an SSH connection out to that server, and we execute those tasks on the server. Now, this page gives you an example of what an inventory may look like. And the first thing you'll notice in the first line is we've got a word in square brackets, which is the word web. And what that does is it provides a group of servers. So the servers that come beneath the word web are the actual host names of the servers that we're going to communicate with. So in this case, there's 2 web servers and 2 database servers that we're going to connect to. And to give you an example of an Ansible playbook, first of all, you'll notice at the top, we list the hosts that we're going to execute this playbook against. And again, going back to that inventory file, we had the web group, which consisted of 2 servers. So in this case, we're going to execute this playbook against the servers defined in the web group. We have the ability to define local variables, such as the HTTP port and the max number of clients. We also have the ability to define what remote user we're going to log into those servers with in order to run this playbook. And then, of course, we have the tasks. And each task has a module that it's going to execute. So this first task, which is install the HTTP daemon, is going to use the yum module. It gives the name of the package and the state of that package, which in this case it means let's install the latest version of HTTPD. The second step, or the second task, is we're going to write a configuration file out to a directory, and then we're going to start this particular service. And if you take this simple playbook and take it one step further, and again, looking that maybe there are multiple hosts in the inventory, this picture shows how it's going to branch out to every single one of those hosts, and it's going to run all of the tasks that are in that playbook. So for example, if you wanted to install this HTTPD service on 20 different servers, you could use this playbook to do it. And again, what it's going to do is it's going to do those 3 tasks. It's going to install the server, copy a configuration file, and start the service. So with one consistent, repeatable process, we have the ability to launch and configure all of those servers. Now, here are some example modules that we have inside of Ansible. For example, we have modules to do copies and files and to get URLs. We have get repository commands, ping commands. Again, there's over 3,000 modules, and that list grows daily. And again, the way that that list grows daily is we're an open source company, and we have individuals who may contribute to our source code repository upstream. So if they have a specific module that they want to add, they have the ability to do that, and then we can take that new module and incorporate it into our enterprise software. If you wanted to see a list of all the modules that are available, you can go to docs.ansible.com, and you could actually start to drill down. And you can see from this screen that we have cloud modules, command modules, crypto modules, database, files, identity. We have a lot of different things that we provide. Another way to get a list of all of the module information is if you've installed Ansible Automation Platform, you can simply do an Ansible-doc and do a -L to list off all those modules. Now the question always comes up, what if there's something I want to do that does not have an existing module associated with it? And for that, Ansible has a way to run an ad-hoc command. And we have 4 different ways that you can do that. One is there is a module called command, and that's going to take the command that you want to run, and it's going to execute it on that host. You could also create a shell script or an actual script, or you can execute the raw command inside of Ansible. Here are 3 different examples of ad hoc commands. We've already seen the first one. We're going to ping all of the servers in our environment. We can also collect and display various facts about the servers that are in our inventory. So for example, here we have Ansible. We want to look at our local host, our current host, and we want to run the setup module, which is going to give a bunch of information about this module, about this server. For example, here's an example execution of this particular module. We've got Ansible localhost -m setup. You can see it gives us the IP address, the alias, the gateway, interface, the MAC address. And if we ran this command, the page actually goes on about 3 pages long for all the data that you can bring back. And what's great about that, again, is you can use this to create reports about your environment, about your network, about all of the servers in your cloud. And you can take that report and you can give it to someone. So for example, maybe you wanted to generate a report which had all the IP addresses and the operating system and the version of that operating system that's running on your various devices. You could actually run this command and you could tell it to filter based on the information that you want to see. So in other words, you don't want to see 3 pages of information, you just want to see exactly what you're looking for. Well, you can create that filter and have it report back only the pieces of information which are important to you. Now on this page, we talk about some of the different uses of Ansible. For example, we can configure all the different cloud environments. We are partners with all of the major cloud providers like Amazon and Google and Microsoft. And we have modules inside of Ansible that allow us to configure those different pieces of the puzzle. We've got operating system commands. We've got virtualization and container commands, storage commands. They're all part of the Ansible ecosystem. Now, there's one component of Ansible that we've not really talked about up to this point, and that's a component called Ansible Tower. And Ansible Tower it's a GUI-based tool or a browser-based tool, which enables you to bring in and store all of these different Ansible playbooks that you may create. Now, the vision that you have to have is that once you start to use Ansible, you're not going to have just 5 or 10 playbooks. You may have hundreds or thousands of playbooks that you want to be able to manage, and you want to be able to configure so that they run at the appropriate points in time. You want to be able to store logging information about what happens when these playbooks run. So there's a lot of different pieces of the puzzle that come together that you want to be able to manage and to store. And that's what Ansible Tower provides to you. Now, what we've been able to determine, we actually had a company that did a study on the financial return on investment for Ansible Tower. And what we've learned is that within a 3-month period of using Tower, you have 146% ROI. You have a 94% reduction in recovery time following a security incident. Now, what I mean by that is once you have created your Ansible playbooks that take care of whatever steps that you do when a security incidents happen, we now have the ability to automate those steps and in the process see a 94% reduction in the recovery time for that incident. We've got an 84% savings by deploying workloads to generic systems and appliances using Tower. And we have a 67% reduction in man hours that are required for deliveries. Now, part of this presentation today, we only wanted to talk for about 30 to 40 minutes. And then we have a lab environment that each one of you is going to have access to. And let's talk a little bit about that lab environment. So at Red Hat, we definitely like to drink our own champagne. This lab environment that we've created for all of you attendees was actually provisioned by, configured by, and managed by Red Hat Ansible Tower. In fact, these workshops are available online. If you go to the link in this corner which says github.com/Ansible/workshops, you can actually look at this material. You can look at the presentation material, and you can look at the labs that we create. And what we're going to do is we're going to use these environments to take you through 7 different labs. Now, these labs are really simple. They take between 5 and maybe 15 minutes for each one of you to do. But basically, these labs are going to be deployed on a Red Hat Enterprise Linux server, and we give you the ability to actually experiment with and learn Ansible as you go. Now, as far as the location for these labs, you can see it's on this screen. I've also copied and pasted this link into the chat window for what we're doing. So with this link, you can see the following. Let me bring it up on the screen. When you look at this window, you can see, first of all, at the very top, we have a link to the Red Hat Ansible RHEL exercises. And if you wanted to see an actual PowerPoint presentation, it's a little bit different than the one I showed today, but you can look at that as well. The one tool that you're going to have installed, if you're running a Windows environment, it's a tool called PuTTY. And with PuTTY, what that enables you to do is to create an SSH connection over to the server environment that we've made available to you. As we scroll down this page, you can see that we've created over, well, exactly 35 different environments. And what I'm going to ask you to do after you access this page is there's a link right here that says, if you're not sure which workbench you're assigned to, click on this link. And with this link, it's going to prompt you for your name and your email address. We don't do anything with this information, but when you click submit, it's going to give you information as far as what environment to work with. So for example, if it gives you student 1, it has all of the different pieces of the puzzle that you need to access the student 1 environment. So for example, in order to access this environment, you would first do an SSH into this student environment, and it gives you the username of student 1 and a password right here that you can use to access this system. Once you've accessed this environment, you would simply then go through, and we're going to talk about each one of these labs. So the first lab is an overview of public cloud provisioning. And what this lab does is it takes you through and familiarizes you with the environment that you're using. It's a very, very simple lab. Again, it may take you about 5 minutes to do. The second lab takes you through an example of converting bash or shell commands to Ansible. And that's where I'm going to take us today, as I want to make sure that we understand how to run these different scripts in Ansible. So let me talk about this second lab. In this second lab, we're going to deal with an inventory. And again, Ansible works against multiple systems by defining what's called an inventory. The inventory is file-based. It can have multiple groups defined inside of it, and it can actually have variables for each group, or even variables for a host. We've seen one example inventory file before. This is a very similar one where we've got a group of web nodes and we have a control node. We also have the ability to define environment variables inside of this inventory file. So for example, maybe we would have an environment variable called user with the value of student 1, or SSH password, or port number. In this example, we have an example of showing you one way in which we converted a bash script into an Ansible playbook. And so when you look at this script, you can see that the first thing that it does is it defines some environment variables called MS-SQL SA password, MS-SQL MS-SQL _process ID or PID. And then it shows you doing the export command and redirecting it to two different files. There's the bash pro file and the bash RC file. And if you look at the right side of the screen, it shows you how we would do that in Ansible. And again, we've got some environment variables at the top, and then we have the list of tasks in the middle, which says add MSQL tools to your path environment variable. So again, this is just an example. But if we go back to the screen, which has the actual lab in it, this gives you the very specific steps that you're going to execute in order to make that happen. So let me open this up to questions. First of all, does anybody have any questions as far as getting this environment, getting access to this environment, and then looking at or being assigned one of the environments to work from?
I think there was actually one question, Jim, that came across from Rob. How long do they have access to the labs after the webinar? Is that something they can access after or just during this time?
So this lab environment is going to be available until end of day today. We actually have, and I don't have any control over that. We have a time bomb built into these environments, which wipes out the environments after a day and a half of use. And you can understand why, because for example, for each one of these students, we've provisioned 4 virtual servers in a cloud. So we have 35 students, 35 times 4 is the number of servers that we provision. But again, you could go through these exercises either now or later this afternoon if you wanted to do so. Any other questions? What I'd like to do is start off with just doing the first 2 labs, and then we can branch out and do the 3rd and the 4th lab. The total elapsed time to do these labs is about 90 minutes or so. So they go very quickly, and if we do them together, if anybody has any questions or issues, then you can voice those questions to me over the WebEx. So let's start there. Are any questions about Ansible in general? And again, Jeff, I don't know if people are muted at this point or what, but
I got a question here. Is there, for Ansible, is there any need for using SSH pass? I think that's what it's called.
Is there any reason for using it? Absolutely. So the pass, SSH pass, is the password. And if you, obviously, if you put that password into a file, it's going to be shown in clear text, which may not be a good thing. But we do have the ability to also leverage keys using a key generator. And so if you have a control node that you want to be able to run scripts on other nodes, you can set up a key between those 2 nodes so that no password is needed. Very good question, by the way.
There's a question in the chat from Rob.
Yeah, I'm not sure if you can see that, Jim, but Rob's just asking, how does Ansible compare to Terraform?
That's a great question. So first of all, at Red Hat, we also use Terraform to do installations. And what Terraform is really good at is performing cloud installations. And one of the thought processes behind that, what it's really good at is every different cloud vendor does things a slightly different way. And Terraform is great for being able to understand the different ways in which cloud vendors do their configurations. So Ansible is definitely a competitor to Terraform, but we also complement Terraform. So for example, you could write a Terraform installation script, which at various points in time can branch out and call or execute an Ansible playbook. Incidentally, we used to use Ansible for all of our installations, like for OpenShift, and we actually switched over to Terraform just because it had more robust functionality for working inside of cloud environments. But I think where Terraform may fall short is just working locally and doing all the different mundane tasks that we do. And it's, I don't think it's as easy to use as Ansible is.
Right. Like, can Ansible really do a lot of the day-to-day configuration and modifications really simply on multiple hosts, and Terraform isn't really used for that?
That's correct. Yeah, I mean, and that's where Ansible shines, is by doing those day-to-day transactions. In fact, one of the use cases I mentioned was using Ansible to configure your security. We've actually partnered with the US government to look at what they call their open SCAP definition. I think SCAP stands for Security Access Protocol. And what SCAP does is it defines how your servers need to be configured in order to make sure that they're completely hardened and secure. When we partnered with the government, we created a user interface that would go out to your server, and it would basically run an Ansible playbook against that server to look for vulnerabilities. And when it came back with those vulnerabilities, it produced a report of everything that was either green, which meant it was okay, or yellow, which meant we could have an issue, versus red, which meant you need to fix this. And what we did when we partnered with the government is we said, we'll not only create this for you so you can get this report, but then if you want to, you can push a button and it'll generate an Ansible playbook, which will go fix all of those issues that you've had with your system. So by simply pressing a button, you can very quickly and easily harden your environment so that there's no vulnerabilities. In fact, you can go, if you have a Red Hat Enterprise Linux system today, you can go out and if you go out to the openscap.com website, you can download the tool and run it on your RHEL right now, and it'll show you all of the vulnerabilities with that machine. So I see another question in the chat. It says, we have similar equivalent product available in the market today. What is making Ansible stand out of the box? So what's making it stand out? I think there's a couple things. Obviously, I don't know what product you're talking about, but some of the features which I discussed, first of all, there's no need for an agent. Almost all of the other management or automation tools require some type of agent to exist on that server. And that can be a challenge. We also have the ability with Ansible Tower to manage all of these playbooks that get created. And with Tower, you're actually going to do an exercise using Ansible Tower. You can not only store your playbooks in Tower, you can define all of the inventory, for example, where the inventory comes from. You can schedule jobs to run these playbooks against a certain predefined inventory. So for example, take security. As you guys all know, if you've ever managed an infrastructure, stuff happens. Somebody may go out to a server and open up a firewall port, which would leave your system exposed. Well, you could run an Ansible playbook that would go and search all of your servers and see which firewall ports are exposed. And if it returns a flag, it can write a playbook automatically, which will go fix that server. And if you do that as a scheduled job to run at night, you know that every day your servers are going to be safe and secure. So it's really the combination of the Ansible automation engine combined with Ansible Tower that provide you a solution that is very robust and makes it stand out in the market today.
Well, and agentless, right? When you install other tools, the first thing you have to do is manually go install 1,000 agents on your 1,000 servers. And
that's exactly right.
Yeah, and so where Ansible, you just plug it in, and as long as that Python then you're good to go.
That's right. You're off to the races.
Well, and also multi-platform, right? I mean, it's like virtually any distribution of Linux and Windows as well. And
that's correct.
So.
Yeah, anything. Windows, Linux, Unix. It can handle all three of those, which again makes it stand out. It's very, very powerful. and its power comes also in its simplicity. It's easy to write these playbooks. It's easy to get up and running very quickly. These are great questions. Any other questions while we're doing this? Okay, so let's do this. Again, each one of you who wants to do these labs, you can either do them now or later. If you do them now, you have the advantage of me sitting here with you if you have a problem or a question. Let's start by doing the first 2 labs. So, overview of your public cloud provisioning and converting bash and shell commands to Ansible. And let's take about 15 minutes to do these 2 labs. Again, in order to access this environment, if you go to this original page, click on this link, which says, basically, if you want an environment assigned to you, give it your name and email address, and it will give you the exact pieces of the puzzle you need to connect. Any questions on that? Okay, so the time now is, let's say it's 1:50. Let's do these 2 labs, and then I'll come back to you at 2:05, and we'll talk about labs 3 and 4. Okay, it's 2:05. Kind of curious if everyone on the call was able to complete that particular lab or those 2 labs. Were you able to get connected using SSH or PuTTY? If anybody is not finished, speak up now, and I'll give you all another couple minutes to complete. Just don't forget to unmute yourself if you want to tell me that we need to extend another couple of minutes. All right, are we good to go? Silence is golden. So let's talk about exercises 3 and 4. So in exercise 3, we're going to write an Ansible playbook. And you've seen this example in my slides previously, where this is going to install an Apache web server. This slide shows that this is the entire play in your playbook. So you've got the hosts that are defined. You've got 3 different tasks. You're going to install the Apache web server, copy a configuration file onto that server, and then start the server. It even breaks it down further to say here is a specific task, and this is the module. Again, there's thousands of modules that are available. In this case, we're going to run the yum module. Now, when you run the playbook from the command line, it will color code the information that comes back to you. In this example, you can see that anything that was expected comes back as green. Anything that was changed will tell you in yellow. And if there's a failure, it's going to tell you something failed. Here's an example of running the playbook. You can see the first task that it does is it gathers facts. Then it's going to ensure that your HTTP package is present. It's going to ensure that this index.html file is copied over. And then it's going to restart the server. And at the bottom, it shows you all of the servers that were acted upon and what the final status was, which it says status of OK equals 1. And it changed 3 things on these servers. Again, there were 3 tasks that were executed, so it changed 3 things. So that's lab number 4. I'm sorry, lab number 3. Let's talk about lab 4. In lab 4, we start to introduce variables into the equation. So in this case, in this example, we see that there are some variables defined. There's var1, var2, and var3. var1 and var2 are obviously just strings. However, var3 uses string substitution. And so anything that's inside of those double curly brackets, it's going to substitute an existing variable. Now the task in this specific playbook is simply going to print out these variables, and it uses a module called debug, and debug has a parameter called message, which is going to list out the message that it's producing. We also have the ability to look at facts. Again, using the AD-Hoc command called setup, we can run a playbook which is going to list off all of the setup information for a particular node or network device. And in this example, we use the setup module to list off all of the IP addresses and the FQDNs of each specific device. So you can see that when it prints out the message, it says the default IP address for this node is this IP address. And again, it uses this setup module to do that. We also have the ability to manage all of our variables. So for example, when I say managing a variable, what if you wanted to, instead of using one playbook to define all your variables, what if you wanted to break them down into different groups? So for example, group variables or host variables. There's a way that you can do that. And it simply defines a folder structure where you can put these various files in the folder structure and then leverage them from inside of your playbook. So for example, let's say we have a group variable called web.yaml, which is going to have one environment variable called stage. We've also got host variables, which has an environment variable called stage. In the group vars, the value is dev, and in the host vars, the value is production. When you go to run your playbook, again, the task that you're executing is going to leverage this module. And in this case, we're going to have an environment variable called stage, which is used to copy the appropriate file from the appropriate directory onto the server that we're wishing to configure. Pretty simple. So that's exercise 4. Tell you what, let's stop at the end of exercise 4, and then we'll talk about exercise 5. So I think exercise 4 should take you about 10 minutes. It's 2:12 right now. Let's reconvene at 2:22. Any comments or questions or thoughts on exercise 4? Okay, let's talk about exercise 5. In exercise 5, we're going to leverage Ansible Tower. Specifically, we've got some pre-existing playbooks or templates that we've stored inside of Ansible Tower. And what we're going to do is we're going to use these templates and create a survey. So one of again, we've seen that in a playbook that we can define environment variables. But if you're running those playbooks from inside of Ansible Tower, the question becomes, how do those environment variables get populated? And one way you can do that is by creating what's called a survey. And that survey can be used to populate or create the definition for the environment variables for the playbook that you're going to run. So in this implementation, Tower is going to allow you to configure how a job runs via a series of questions. And it's going to make it very simple to customize your jobs in a user-friendly way. Very simple to create a survey. You'll notice that on this page first, it's clicked on a template. And the template is called createindex.html. We click on the Edit Survey button. And actually, I think this screenshot is incorrect. It actually is add survey. And then the survey window comes up, and you can simply fill in the information in order to create the various fields for the survey. And then when you use the survey, when you launch the job, the user is going to be automatically prompted with the survey information. And then it'll run that job, and you can actually watch the job run inside of Ansible Tower. So that's exercise number 5. If you have a question, please ask now. Otherwise, let's take about 10 minutes to do exercise number 5. All right, is anybody not finished with exercise 6? All right, let's talk about exercise 6. In this case, we are talking about Linux roles, or I should say Ansible roles. Now, what's interesting is Ansible has some websites that provide free playbooks, both to those who are subscribers to Ansible and those who are not. The one that's available for those who are not paying, or I should say who do not have a paid subscription, is called Ansible Galaxy. Ansible Galaxy is where it's a repository where anybody can check in or add a playbook to that repository. And if you go look at that repository today, you'll see thousands of Ansible playbooks. Now, the challenge with that, even though it's great, people are submitting playbooks and not charging you for it. The challenge is we don't know if the playbooks work. They're definitely not certified. And it's entirely possible they could have information in the playbook which compromises your security. But that's not to say you shouldn't use them, because obviously once you download the playbook, you can read the playbook and see everything that it's doing. The other repository that we have is called the Ansible Automation Hub. And the difference between these two repositories is the Ansible Automation Hub is certified. Everything that you find on the Automation Hub has been fully vetted, tested, and verified either by someone at Red Hat or by a Red Hat partner who contributed that particular playbook to the repository. And what that means is if you download the playbook from the hub and you find an error or you experience a problem, you can come back to Red Hat and get support for the issue that you've discovered. And again, the individuals who would contribute to this are either Red Hat partners or Red Hat employees. Any questions on that? When you think about a role, first of all, I have to admit, I don't like the name of this particular feature, because when I think of a role, I think of like a user group and the roles that are associated with that group, like the permissions that you have. And that's not the case at all when you think of an Ansible role. What an Ansible role is it's basically, let's say, an archive file, a zip file, which when uncompressed provides a directory structure. And in that directory structure, you have folders for the various pieces of an Ansible playbook. So for example, you may have a folder called variables or a folder called tasks. And in these different folders, you're going to have a YAML file which communicates or conveys that particular piece of the puzzle. So in the folder called variables, there's a YAML file that when it's brought into the system will have all of the variables that that playbook needs to use. what this provides is a very convenient way for you to share your playbooks, to share the structure of a playbook. And then what you can do is you can create, let's call it a master playbook, which has tasks defined. And you can actually link these roles together as tasks. So in this example, the first task is configure a firewall. And it's going to use a role which we've downloaded called Linux System Roles.firewall. And again, this would be a playbook that has all of the different steps or tasks that are associated with that particular play. And the second task would be configuring the time sync. And again, this is a role that you download and you include it in this playbook. So when I go back to the system, the lab environment, you can see that exercising these roles, you're going to examine the Ansible project, examine the playbook, look at the roles, launch the job, and verify its completion. It's pretty simple. And this is actually the last lab that we're going to do today. Or is there? Actually, there's one more. Is that right? I think that's the last one. The lab on insights was actually removed from this environment. But with that being said, any questions on lab number 6?
There was a question posted from Ganesh about the Automation Hub, asking if it's free of charge.
The Automation Hub, you only have access to if you have a valid Ansible subscription. So a subscription to the Ansible Automation Platform. And that's the difference between the two. The Automation Hub is you have to have a subscription versus Ansible Galaxy is free. All right. Any other questions? Excellent. Again, this will take you about 10 minutes to do. It's 2:37. I'll come back at 2:47 and we can wrap things up. And again, this is almost exactly an hour and a half long in time. If there's any other questions, any questions whatsoever about Ansible or about any other Red Hat products, please feel free to ask at that point in time. Okay, it's 10 minutes. Is everybody finished with that lab, or is anybody not finished? You guys want to take yourself off mute? Let's have a few minutes of just talking about this. Tell me what you liked, what you didn't like. This is actually one of the first times we've done this particular lab. We've got previous labs that actually take about 3 or 4 hours to do, so we do a lot more depth. But with coronavirus and people working remotely, we decided to scale it back a bit and make it more streamlined. So I'm definitely open to your feedback, or if you have any other questions.
Looks like we have another question from Ganesh. Jim, I don't know if you can see that in the chat session.
I see it. So commands and playbooks against a remote node, is there any option of getting back the results of them as an attachment and broadcast the info via email? Just want to check if there's any feasibility of doing this action. So if you are running the playbook inside of Ansible Tower, it automatically records log information for everything that happened in that playbook. So for example, if you wanted to schedule a job that kicks off at midnight and you want to come in the next day and look at the log, you can do so. And I believe there is a way to push those log files to other servers as well if you wanted to read them remotely or to, I've never sent an email with one So I'd have to check to see if that were possible. But the short of it is you do have the ability to create log files and do something with them. Now, I guess the core of your question is if you're running an ad-hoc command, I mean, you can run an ad-hoc command inside of a playbook as well, so that could still be logged. All right, silence is golden. Well, I thank you again for attending this workshop. With that, Jeff, I'm going to turn this back over to you.
Yeah, thanks everybody. Thanks for your time today. Very much appreciated. Take out of a busy day. Just a quick note, after the workshop, I'm going to send out a quick survey to everybody who joined in today, just so we get a little bit more feedback. We really like to continue to offer these types of webinars and workshops. We want to know, how we do better. Just a little bit of feedback will certainly help us out. Also, I'll be sending out a link on the next day or so to the recording if anybody's interested in that. I will be filling it out, so just let me know. Other than that, thanks, guys. Have a wonderful day.
Yep, thank you all.
Thanks, everyone.